we're going to look at trigonometric identities. Trigonometric identities are somewhat like proofs in some ways. You're trying to show that two things are equal by taking steps to show how you can turn one thing into another. In some ways, they're like a big puzzle. As long as you have two things that are equivalent to each other, you can always replace them with their equivalents. So for example, our reciprocal identities, we've seen them before. We could replace the secant of A by 1 over the cosine of A. Or we could also replace the cosine of A by 1 over the secant of A. We could replace tangent of A with sine of A over cosine of A. Or we could replace sine of A over cosine of A with tangent of A. We've used the Pythagorean identities before. Cosine squared of A plus the sine squared of A equals 1, etc. Pythagorean, reciprocal, and ratio identities are used often. Those are the ones that you're going to go to most. Cofunction identities and even and odd identities occur sometimes, but not all that often, and use them as a last resort. Some helpful hints. 1, know your Pythagorean, reciprocal, and ratio identities. You're going to use them over and over and over again. 2, always work on the one side. If you get stuck, start over from the beginning on the other side. We always have to start at the beginning again. 3, try to get both sides of the equation in the same trig function. Also, it can be useful to try to get things into sine and cosine. Sine and cosine are more friendly than things such as secant and cosecant. 4, remember the difference of squares. It occurs often in these problems. A squared minus b squared is equal to a minus b times a plus b. Practice, practice, practice. The only way you're going to learn how to do this is to keep practicing. The more times you see these types of things come up, the more you're going to be able to understand and look at a problem and know where you should even start. 6, always start with the more complicated side. We always want to start with that more complex side. So let's dive into example. Example 1. Use the following algebraic techniques to simplify trigonometric equations. So part A. Part A says to simplify cotangent of theta divided by the cosecant of theta by rewriting each trigonometric function in terms of sine and cosine. So, cotangent of theta. Well, we know that cotangent of theta, that's a ratio identity. Cotangent of theta is equal to the cosine of theta divided by the sine of theta. And the cosecant of theta, we can rewrite that using a reciprocal identity. We know that the cosecant of theta is equal to 1 divided by the sine of theta. Where do those come from? Look at the very top of the page. So now, we're going to replace cotangent with cosine over sine and cosecant by 1 over sine. So, cotangent of theta divided by the cosecant of theta is equal to the cosine of theta divided by the sine of theta all over 1 divided by the sine of theta. Now remember, when you divide fractions, you multiply by the reciprocal. We now have cosine of theta divided by sine of theta times the reciprocal, which is sine of theta divided by 1. When we multiply fractions, we multiply straight across. This will give us cosine of theta times sine of theta divided by the sine of theta, which the sine of theta, those become a giant 1, or they cancel each other out, and we are left with cosine of theta. So notice how we went from something that looked somewhat complex and ended up with a single function. We will not always end up with single functions, but we usually are going to try to get something that is less complicated. Part B. Show that cosine of theta over 1 plus the sine of theta is equal to 1 minus the sine of theta divided by cosine of theta by multiplying the numerator and the denominator by 1 minus sine of theta. We're going to take this left side and we want to multiply it by this in the numerator and the denominator and simplify and see if we can get it to be 1 minus sine of theta divided by cosine of theta. This is a key tip to solving some of these problems. We call this the conjugate. The conjugate has the same values but a different sign in the middle. And you'll see what's going to happen here. We're going to take cosine of theta divided by 1 plus the sine of theta and multiply by 1 minus the sine of theta divided by 1 minus the sine of theta. When we do this, multiply straight across. So we get cosine times cosine of theta times 1 minus the sine of theta. I'm going to leave that like it is for now and see what happens in the denominator. When we multiply these two things, it's a binomial times a binomial, so you either have to use the distributive property, some of you might know it as FOIL, or the box. However you want to do it is fine. However you did it in algebra, that works. So 1 times 1 is 1. 1 times negative sine is negative sine of theta. Sine times 1 is positive sine of theta. And positive sine times negative sine of theta is negative sine squared of theta. Now notice, negative sine of theta and positive sine of theta, those two are going to go away. They add to be 0. The reason why we multiply by the conjugate is because it's going to help us get rid of this sine of theta in the denominator. So now, we have in the numerator, this was kind of like step 1, this was 2, here we are at step 3. So we have cosine of theta times 1 minus sine of theta divided by 1 minus sine squared of theta. Now, sine squared of theta, that comes from a Pythagorean identity. That comes from, or we have cosine squared theta plus sine squared theta is equal to 1. And if we were to subtract sine squared of theta from both sides, we would be left with cosine squared theta is equal to 1 minus sine squared theta. We have 1 minus sine squared theta here in the denominator, so let's replace it with cosine squared theta. And the reason we want to do that is because we have a cosine theta up in the top, and we're trying to get this 1 minus sine theta in the numerator by itself up here. So if we can get this denominator to be a cosine, we'll be able to divide away a cosine. So our fourth step, we're still leaving cosine of theta in the numerator times 1 minus sine of theta. And we're going to divide by, instead of 1 minus sine squared theta, we're now going to divide by cosine squared theta. Cosine squared theta is the same thing as cosine times cosine. So one of the cosines in the bottom cancels with one of the cosines in the top. When we do that, we are left with 1 minus sine of theta in the numerator divided by the cosine of theta in the denominator, which is what we wanted to get to. So notice how multiplying by a conjugate can help us in many ways. Here we want to simplify. And we have two fractions that are being added together. When we add fractions together, we need to make a common denominator. So we're going to multiply the left side by cosine of u over cosine of u to get a common denominator. And on the right side, we're going to multiply by sine of u over sine of u. So on the left, cosine of u over cosine of u times 1 plus sine of u divided by the sine of u. We're going to add that to cotangent of u minus cosine of u divided by cosine of u times sine of u divided by the sine of u. We do that because now cosine times sine and cosine times sine, we're going to have a common denominator, so we can add. In the numerators, we're going to distribute. So cosine of u times 1 leaves us with cosine of u. Cosine of u times the sine of u leaves us with cosine of u times sine of u. And then in the denominator we have cosine of u, sine of u. Now notice, you cannot cancel these. This is a sum. We can't cancel things in a sum. And that would just undo everything that we just did because we wanted cosine in the denominator, so we would have a common denominator. On the right side, we're going to distribute sine of u to cotangent of u. So we get sine of u times the cotangent of u minus cosine of u times the sine of u divided by cosine of u times the sine of u. When we add fractions, we add straight across the top. So we will have cosine of u plus the cosine of u times the sine of u plus the sine of u times the cotangent of u minus the cosine of u times the sine of u, all divided by the cosine of u times the sine of u. Now if you notice, we have cosine u, sine u, and negative cosine u, sine u. Those will cancel. So now we have cosine of u plus the sine of u times the cotangent of u divided by the cosine of u times the sine of u. We're getting a little bit more simplified. This was step 1, 2, 3, and this is step 4. This cotangent of u isn't all that friendly, so let's replace it with something. If we think about our ratio identities, cotangent of u is equal to cosine of u divided by sine of u. So we're going to replace that here. Our fifth step, cosine of u plus sine of u times cosine of u over sine of u, all divided by the cosine of u times the sine of u. These signs are going to cancel, and we'll have cosine of u plus cosine of u. That happens to be 2 cosine of u divided by cosine of u, sine of u. And the cosines will cancel. We're left with 2 divided by the sine of u. So you could leave it like that, or you could write it as 2 times the cosecant of u. So either one of those would be an acceptable answer. Factoring. Factoring comes up a lot in these problems. If you see something squared, you might be able to factor. Sine squared theta minus 1, that is a difference of perfect squares. When we factor it, it becomes sine of theta minus 1 times the sine of theta plus 1. In our denominator, we have a tangent in both of these, so we could factor a tangent out. We have tangent times sine of theta minus 1. Now if we notice, we see sine of theta minus 1 and sine of theta minus 1. Those are going to cancel each other out. We are going to be left with sine of theta plus 1 divided by the tangent of theta. We could change the tangent of theta into sine over cosine. However, that doesn't help us to simplify anything, so this is just going to be our answer.